This is Greg Troutwine with Maritime Reporter TV, and we're very pleased to be joined today by Harry Ward, the president, and Charles Sterling, the Digital Inspection Director of DLS Marine, to discuss remote inspection technology in the maritime sector. This discussion will not focus solely on the theoretical and the possibilities, rather on actual deployments. To start us off, can you give an overview of DLS Marine today?
DLS is a 56-year-old company. Founded in 1968. Norm Dufour was the main driving force. I think probably a lot of people who see this will know Norm or know of him. So we have I've been the owner for about the last 7 years. We have 40 people in the company. We're sitting in our office in Metairie, just outside of New Orleans. So that's the main office. We've got a small office in Houston, Tampa, Norfolk, Virginia, and then we have one surveyor up in New England, basically. So we've done a few things over the years. We added a cargo group. So we're one of the first companies that had both cargo surveyors and hull and machinery surveyors. So that was one innovation that the company kind of undertook in the 90s. And then in 1991, we actually had the first ASA, so that's American Society of Appraisers, accredited appraiser focused entirely on the marine industry. So that was another area that we led, and I think we continue to lead. We have 6 accredited appraisers right now. So that's really important to our clients, especially the financial, like the private equity groups, and especially the large banks that are underwriting all these fleets of vessels. So that's kind of a core competency of DLS over the years. But we also are leading this charge into different inspection technologies and especially digital. So
excellent. So Charles, just briefly, can you just give an overview of your title and your area of responsibility? How long you been with DLS?
Sure. Well, I started with DLS last year. I did some contract work for them this past in 2023 in June for an oil spill, and they called me and wanted to meet. So we started collaborating, and I started back in December of 2023. They hired me on as their unmanned aircraft supervisor and digital inspection manager to kind of push that whole initiative through to integrate digital inspections into their current workflow for better outcomes. Yeah,
and I'll just tack on to that. So Charles had his own consultancy, was doing a lot of work, and also has a really strong IT background, which has become real important through this entire process, because we're evaluating software, we're sort of helping to write some software. So it's more than just flying a drone. There's a lot of processing that's necessary. That's been really helpful for us.
Can you discuss the opportunity in the round that you see in terms of remote inspection for maritime and the offshore energy space?
It's hard to put numbers on it, but I'll start by saying we think it's enormous. And we've really been at this for, I'm going to say, 6+ years at this point, trying out drone technology, other digital inspection technology, and playing around with different software. But the truth is, really, it's just in the last couple years that those sort of things have started to mature to the point where they're really, truly useful and can put out a good product. So it's walking the walk. I think a lot of people have tried it. It's more endurance. I think you have to hang in there and just kind of keep trying different things. And we're still learning every single day when we're doing this. But at this point, I think it's in areas where you can actually be more efficient, provide a better deliverable, and especially be safer. And the things we've been doing recently check all those boxes. And that is a huge business just in itself. So, for example, tank inspections on large blue water ships is something that we've been doing. And you can kind of, we'll talk about it more, but you can kind of imagine how this kind of technology would leapfrog what people are doing today.
So, specifically then, and I know everything in any business is all about investment in the next generation of technology, the next generation of people. But can you discuss specifically how DLS Marine has invested in technology and talent to fast forward your ambitions, and specifically in the remote inspection space?
Yeah, by putting a lot out and not getting much back yet, like any early investment. But again, we're super excited at this point because we, as I said, kind of invested in different levels of drones over the years. But then when Charles came on board, our ability to analyze what's out there, pick the right things, and really start moving forward has, really kind of coalesced. So we've spent a lot of time evaluating software, evaluating drones, and then, investing money in the ones that make the most sense. So that's been a lot of Charles's job.
A lot of testing too. And the problem is that with the newer generation coming up, they will be more technology centric. So for instance, right now, luckily for me, I got an IT background, so I know CAD, I know AutoCAD, I know Civil CAD. So to have a good deliverable is to be able to, like we were talking earlier, is to be able to mobilize, capture, attack the job, get a great deliverable. But then what do you do with that? Sometimes you may have to come back and convert that to a CAD file for a customer. So it's multiple dimensions within the whole industry, if that makes sense. So just hiring somebody to be a drone pilot, they probably need to have a little more background and the area they're working and software to be able to get that deliverable and deliver it in a timely manner. Yeah.
And then we're constantly really kind of giving feedback to the technology providers that we have too, and working with them and kind of helping them in some ways, because we're doing some things that frankly haven't been done before. I mean, there have been people doing some drone tests on vessels and inside of large spaces, but we're truly getting to the very confined, like ballast tanks, where there's a lot of challenges to overcome. So it's a little bit of a two-way street of the information too, but the investment is on our side, and we've been doing it, and I think it's getting to the point where it's going to pay off.
Luckily for us, we're big enough that we touch a lot of different varieties of vessels and assets. And we're small enough that we can work with those vendors to test their product.
Right.
Where a lot of larger companies may just buy the technology, use it, not really collaborate with them. So we're actually, helping them, make their product more streamlined and better, more efficient. At the same time, it's helping us. So we're in a great place for that.
When you look at marine, there's a lot of different spaces, as you said. There's the whole ship or the whole rig, the whole unit inspection. There's the big tanks, but then you have a bazillion small little spaces. My long-winded question, can you kind of discuss some of the specific challenges that you see in maritime and offshore, and kind of how your investment has helped to facilitate your injection into that space?
I think part of the answer is the scale of the things that we're surveying, right? So we do, stepping back, with our hull machinery group, we've been doing sort of traditional surveys for decades and decades, so walk around, take pictures, and we continue to do that, and that's very important, and it will be. But there's certain areas where the technology can help you step back and take a much bigger look around a vessel, and even do things like 3D modeling of the vessel. So like one of these drones might be a part of that process. And then there's also some internal walkthrough technology that we're working on right now. So
360 video, which actually splices that together, so you have a virtual tour of that space and you can actually notate on it. But the confined space drone interior GPS denied drones, I think the ship that we did last, the ballast tanks, 60 feet deep, I guess, maybe, 3 levels. Before you'd have to put scaffolding in there. I mean, we're in and out. I don't know how long it takes to put scaffolding, but probably before they could put up and take down scaffolding, we're in and out with a visual record, a LiDAR point cloud for engineering, and not just one set of eyes and a flashlight giving you feedback in a report. You can go back and look at it, and you actually have a digital twin of that asset and that location on the timeline that you can go back to and refer to. If something else happens in the future, you can go back and say, what did it look like at this time? So once you start developing that historical timeline, then you have a linear record of that vessel's life.
Can you talk a little bit about the classification aspect of it and the approvals that you have?
Sure. Yes, we are remote inspection technology approved by ABS. We have a certificate, so we can go do close-up inspections with digital technology, basically. So it's been an important thing, and this case study that we were talking about is heavily involved ABS, and again, everyone was happy with the outcome.
So I understand that you recently completed your first big job with a new drone on an MSC tanker in Mobile, Alabama. Can you discuss the specifics of that job, illustrating how the work is traditionally done, which, Charles, I think you've already kind of discussed, but how it was done using the DLS Marine drone technology, and finally the tangible benefits that the vessel owner operator enjoyed?
Sure, yeah. So again, it was confined space inspection of ballast tanks, specifically in this case. And ABS was on site, and we were able to enter the tanks. We have our drone here in the middle that Charles called it, he mentioned it was GPS denied. So meaning it actually only operates internally in spaces. So it navigates and paints the entire thing with a LiDAR. And I'll let you talk about that. But yeah, we were able to go in, get a LiDAR navigation and point cloud, it's called, of the entire tank, and then give very specific and up close high resolution digital video and images of the entire tank, while the ABS team was able to watch it either inside or outside the tank, however they chose. So
Yeah, we could drop with this right here. This is it has LiDAR, which generates the point cloud. It also has a gas sensor too, which detects, I think, 22 different gases: gasoline, methanol, all the fugitive gases. Like he said, it is GPS denied. So it provides basically a point cloud within 1 to 1.3 centimeters of accuracy, 4K video. During the inspection, while we're actually flying, you can actually take a point of interest. It actually puts it into the model. So when you're reviewing it in the portal, you can see where that photo was taken, point of interest. ABS was down in the tank sometimes, but it was kind of warm. And with our ability to be able to broadcast it on deck, up top, they opted to stay up on top deck after that and watch it on TV. So they actually viewed it in real time while we were doing it down below deck. And it went a lot faster and a lot better than what they thought. And we were really happy with that. Since it is GPS denied, it uses the LiDAR for obstacle avoidance. So you can turn the obstacle avoidance off, and no, it's not automated. You have to fly it manually. So we had to come up with flight patterns. When we take off, we go to the same spot, whether we're in the aft of the ship or forward. We start the same spot, go clockwise, so that we always know the routine. And it's tethered with power. So we really don't have to stop. So if the tank was 100 miles wide, we could fly it for 100 miles. So we don't have to worry about batteries, which could be an issue too in some tanks, because lithium ion is not a stable substance and can be very explosive. So we're going in there with a grounded tether right into a compartment. We hope salt water was in. We don't know. But as we fly through, it's actually giving us the gas readings. The LiDAR gives us the obstacle avoidance. You have obstacle avoidance on the top and the bottom. So it tells you exactly where you are in the tank on the telemetry at all times while you're flying. So you can fly in some very tight spaces and get some really good results.
So yeah, it's not automated. We are starting to call it Maverick because he flies this thing in confined spaces where no one else is flying these right now. But yeah, and the other point with the tether, and you mentioned it, but is allows you to not have batteries. It grounds it for more safety, and then it provides real-time, high-res data feed, so that not only can you watch it outside of the tank, but we could also beam it via the internet, so that theoretically at some point, let's say an ABS inspector could be watching this live from Houston while we're doing the inspection somewhere else in the world.